Hello everyone, welcome back to another EViews video tutorial. My name is Juan and today I'm going to be covering the topic misspecification in ARCH models in EViews. So today I'm going to be showing you some of the cases which are going to be indicating you that your ARCH model is not specified properly and you will need to do some modifications to it. It's very important that you first watch my tutorial where I teach you how to estimate ARCH models, because in this video I'm not going to be estimating the ARCH model again, but I'm going to be showing you some cases that will be presenting problems to your estimation model. So let's begin. Let's see which are the common issues that you can face when you're estimating ARCH models. So we're going to be reviewing today the following three cases. The first case is you don't have enough ARCH terms, and what's going to happen then is that you will still be in the presence of heteroskedasticity. The second problem is that maybe you have included so many ARCH terms that your ARCH terms become negative. And because we are talking about modeling the variance, these numbers cannot be negative. And the last scenario is that many ARCH terms, sometimes what can happen is that the older terms will have more impact than the recent terms. So this is something that is not appropriate in ARCH models. You would also want to make sure that all your ARCH terms have more impact the recent terms than the older terms. So we're going to be covering this now in the coming slides, so don't worry, we're going to go through each of these cases. Recall, when we are estimating ARCH models, you first need to specify the mean equation. For this example, it was just an R specification, and these error terms will follow a normal distribution, but the variance will be changing over time. That's why there's an HT, which means for heteroskedasticity. So this is the way we are modeling the variance. Then with the ARCH models, we are including a constant term, and then we're including the past square residuals. And the following thing are the requirements that needs to satisfy. As I mentioned, alpha 0 has to be bigger than 0, alpha 1 has to be bigger than 0, and all the other alphas that you include, so all the ARCH terms, have to be positive to guarantee a positive variance. The second thing that we know is that when you add up all these ARCH terms, you have to add up to 1. If all your ARCH terms together make over 1, the unit, then you're going to be in troubles. And the last thing that I mentioned was that the alpha 1 should be bigger than alpha 2 and bigger than alpha 3 and bigger than alpha n, because what we are saying here is that recent past has more influence than older lags. So what happened yesterday will have more impact than something that happened maybe 10 years ago. The model that we had estimated was the ARCH2 model. This was the mean specification, and this was the variance specification. As we could see, the variance adds up to 8 if we add these two terms. And what we are saying then is that the persistence of the volatility is higher the closer that it gets to 1. In this case, it's 0.8, so it's quite close to 1. The volatility persistence is quite high. Let's go now into EViews and let's see what are the common mistakes that we can do when we're trying to specify an ARCH model. We are in EViews. I'm going to show you now the first common mistake, that is not including the necessary ARCH terms that requires your model, and then you're going to be still in the presence of heteroskedasticity. Remember that we have here our ARMA model that we had estimated for the returns of the Toronto Stock Exchange, and we have gone into view, residual diagnostic, and correlogram of the square residuals, and this will give us some indications of how many ARCH terms we should include, and for that we should look into the partial correlation. So here in the partial correlation, as we could see, there were some possible specifications that we could do, and we had decided for 2 ARCH terms. But let's look at what happens if instead of 2, we estimated an ARCH1 model. So I'm going to go into quick, estimate the equation. I'm going to select in the method ARCH, and we have to first here, we have to type the equation, that it's returns, followed by a constant, the AR1 term, the MA1 term. This is for the mean equation. And now for the ARCH, we're going to delete here the GARCH term. We're going to put 0, and we're going to leave 1 ARCH term. And let's see what happens. I hit OK. Here the variance equation is telling me that is appropriate including this ARCH1 term. But let's see what happens with the variance. If we go into view, residual diagnostic, and the parallelogram of the square residuals, what we are going to see is, with including only one arch term, the square residuals are still looking like there could be some more arch terms that you could include, because as you can see, there are some significant terms. There are some terms that are exceeding the confidence bands. Let's do the formal test. We can go into residual diagnostics, do the arch test, and let's go with the arch heteroskedasticity test with one lag, because that's how many lags we included in our arch model. And we can see that the p-value is smaller than 0.05. Remember that the null hypothesis is that there is no heteroskedasticity, so we are rejecting that hypothesis. We are saying in this case that we are still in the presence of heteroskedasticity. So estimating an arch 1 model is not going to be solving my problem because we still have the issue with heteroskedasticity. The second common mistake that can happen is including too many arch terms. When you include too many arch terms, some of those terms may become negative, and that's going to be violating the restriction that all your arch terms should be positive. So let's take a look at, again, this is the square residuals of my ARMA 1.1 model of the returns. So what we're going to do is then we could possibly fit an arch 8 model even. So I'm going to go into quick, estimate equation. I'm going to select arch. Here we need to type the mean equation, which is going to be, remember, returns, the constant, my AR1 term, my MA1 term. In GARCH, we're going to put 0 terms. And in arch, we're going to write 8. So what we can see here now is that we are given all the arch terms that we have included. We included 8. But as you can see here in the coefficient, some of these arch terms become negative. The fifth arch term is negative, and 7 is also negative. So this is another misspecification. Including many arch terms is going to result in some of those terms becoming negative. So as you know, this can happen. And in this case, if you have very few arch terms and you still have heteroskedasticity, but if you are including too many terms and the terms are becoming negative, what you will have to do is to try with a GARCH model. The last common mistake is including many arch terms that can result in some of your older lags to have more influence in the present than your recent lags. So what I'm going to do is go into quick, estimate equation. We already know we have to go into arch and our model. We need first to write the mean equation. It was returns, the constant, the AR1 term, MA1 term. In GARCH, we're going to type 0. And now let's try with 4 arch terms. When we include 4 arch terms, what you can see is that the 4th term has more influence than the 3rd term. So including 3 terms looks like it's fine. We have 0.31, 0.22, 0.12. But then when you include the 4th lag, then you're going to see that this lag has more influence than the 3rd lag. So this is another type of misspecification that can happen. In this case, I would suggest that you remove the 4th lag, just keep it at 3. And if that doesn't help with your heteroskedasticity problem, then you would need to move to a GARCH model. That's going to be all for today. I hope this helped you to determine how to correctly specify an arch model. I invite you to estimate again the arch 2 model and go through the heteroskedasticity test and verify that actually including 2 arch terms is going to be mitigating heteroskedasticity. Thanks again for watching, and I would like to invite you to subscribe to my channel if you would like to get more content related to applied time series and forecasting. Have a great day.